Hello, in this lecture we will study McNemar's test, one of the most useful non-parametric tests for paired categorical data. It is commonly used in before and after studies, medical research, educational interventions and behavioral studies. If you have two independent groups with categorical data, use the chi-square test of independence. If you measure the same individuals before and after an intervention or under two conditions, use McNemar's test. Notice that the same employees are measured twice. This paired design is the key reason why McNemar's test is appropriate. The chi-square test assumes independence between observations. McNemar's test does not. It specifically analyzes changes within the same individuals. The diagonal cells represent people who did not change. The off-diagonal cells represent people who changed. McNemar test is based only on those discordant pairs. Unlike the chi-square test, McNemar's test ignores the diagonal cells. The test focuses entirely on individuals who changed from one category to the other. McNemar's test uses only the discordant counts represented by B and C. Many software packages apply the continuity corrected version by default. Just see how 1 has been reduced from the absolute values of B minus C. Just see how I have calculated chi-square. Chi-square is equal to absolute value of 10 minus 15 minus 1 whole square divided by 10 plus 25, which comes out to be 5.6. Now, if you want to calculate p-value, you can use Excel sheet using the command chi-square dot dist distribution dot rt. Chi-square dot dist dot rt, within bracket you will put chi-square stat and degree of freedom to get the p-value if you are doing manually. See, conventionally, if significance value is less than 0.05, in the social sciences, we say it is statistically significant, meaning we reject null hypothesis and accept alternate hypothesis. If the significance value is more than 0.05, we accept the null hypothesis. Unlike the chi-square goodness of fit example, McNemar's test requires one row per participant because the pairing between before and after responses must be preserved. I will show you an example in Excel how data is gathered and then we import data in SPSS. What is the SPSS procedure? Let us perform McNemar's test in SPSS. After entering the data, go to the menu, Analyze, then Descriptive Statistics and choose Cross Tabs. Place the before variables in rows box and after variable in the column box. Next, click on Statistics and select McNemar. You may also keep the chi-square option unchecked because our objective is specifically to perform McNemar's test for paired data. Click Continue, then OK. SPSS will generate the contingency table along with the McNemar test results. Remember, unlike the ordinary chi-square test, this analysis recognizes that observations are paired. Every row in our data set represents the same individual measured twice. Let us perform SPSS function. I have created an imaginary data to teach you McNemar on SPSS. We have got this file and there are three variables: ID, before, after. For instance, in case number 1, before is yes, after is yes. And similarly, you can see yes, yes, yes. And then there are similarly here no and yes, yes sir, no. So there are 100 entries. I will import these entries into SPSS. Let us see. So we have taken up this file from Excel to SPSS. We'll go to Analyze, go to Descriptive Statistics, and then Cross Tabs. And in the Cross Tabs, we will see before rows, after columns, and then in the statistics, we will select McNemar. We'll select McNemar. Set continue. And if there is any other requirement, you can see other requirement if it is required in your cross tabs. Otherwise, it's okay. Just say okay. So we have got a table. This table has been created by SPSS itself. So that is that is 35 no, and yes 30, but we are interested in this 20 and 25. Yes, so yes, we have changed from yes to no, 25. Let us now interpret the SPSS output. The first table is contingency table. This table shows how many participants remained in the same category and how many changed. Notice that 30 participants answered yes both before and after the intervention, while 35 answered no both times. These are called the concordant pairs because their responses did not change. Now look at the off diagonal cells. 10 participants changed from yes to no and 25 changed from no to yes. These are called discordant pairs. The second table reports the McNemar test statistics and the significance value. Our decision is based entirely on the p-value. If the p-value is less than 0.05, we conclude the intervention has produced a statistically significant change in responses. Let us now perform exactly the same analysis in Python. We first import the NumPy library to create the contingency table and then import the McNemar function from stats model package. The contingency table is entered exactly as shown in SPSS. The first row contains the participants who answered yes before the intervention. The second row contains those who answered no before the intervention. Similarly, the columns represent the responses after the intervention. The McNemar function performs the statistical test and returns both the test statistics and corresponding p-value. This demonstrates that Python can perform exactly the same analysis as SPSS using only a few lines of code. Let us work on Python. I have already started Jupyter as an editor and written the commands import numpy as np from stats models dot stats dot contingency underscore tables import McNemar table is equal to np dot array 3010 25 35. Both are in square brackets, and then square brackets are closed second time, and then normal brackets are closed. So see how the table has been written. Result McNemar table exact is equal to false, correction is equal to true, print statistics result dot statistic, print p-value result dot p-value. So p-value, if it comes with many decimals, you can round off that up to 3 decimals. We have already discussed in many videos earlier. We will run this while the system imports NumPy and McNemar. So it will take some time to run the. So we have got the statistics 5.6 as we calculated manually, and p-value is 0.01799604. So many decimals are there. If you want, you can round up to 3 decimals. You can see how we have rounded it up to 3 decimals. Python now reports two important values. The first is McNemar test statistics and the second is the p-value. The interpretation is exactly the same as in SPSS. If the p-value is less than the chosen significant value, usually 0.05, we reject the null hypothesis and conclude there has been a significant change in responses after intervention. If the p-value is greater than 0.05, we conclude that the observed differences could simply be due to chance and there is insufficient evidence to claim that intervention produced a real change. Always remember that software may present the output differently, but interpretation remains exactly the same. See the slide. This comparison is one of the most important concepts in today's lecture. Many researchers mistakenly use ordinary chi-square test for before and after studies. This is incorrect because the chi-square test assumes that all observations are independent. McNemar's test is specifically designed for paired observations. The chi-square test compares two independent groups, whereas McNemar's test compares the responses of the same individuals measured at the two different times. Another important difference is that the chi-square test uses information from all the cells in contingency table, while McNemar test It focuses only on discordant pairs, that is the participants whose responses actually changed. If you remember this difference, you will rarely choose the wrong test. Let us now discuss some common mistakes that students and researchers frequently make. The first mistake is using McNemar's test for independent samples. Remember, McNemar's test is valid only when the same individuals are measured twice. The second measure is entering percentages instead of actual frequencies. Statistical software requires frequency counts, not percentages. The third mistake is ignoring the pairing of observations during data entry. Every participant must have both before and after responses recorded in the same row. Finally, the researchers sometimes use the McNemar's test even when the outcome variable has more than two categories. In such situations, other methods should be considered. Avoiding these mistakes will greatly improve the quality of your statistical analysis. Before concluding, let me share a few practical tips from a researcher's perspective. McNemar's test is designed to detect change in paired categorical data. It does not measure association or correlation. It specifically evaluates whether the pattern of responses has changed. Always preserve the pairing of observations. If the pairing is lost during data entry or analysis, the result will no longer be valid. When the number of discordant pairs is very small, the exact version of McNemar test is generally preferred because it provides a more accurate p-value than the asymptotic approximation. Finally, when reporting the results, include the test statistics, the p-value, and clear statement explaining what changed as a result of the intervention. One characteristic of the good researchers is that they report statistical results in a standard format. For example, McNemar's test indicated a statistically significant change in employee compliance following the training program. Chi-squares equals 5.76 and p equals 0.016. Notice that this statement includes the name of the test, the chi-square statistics, and the p-value, followed by meaningful interpretations in plain language. Avoid writing only the result was significant. A good research report always explains what statistical results means in the context of the study. Before we conclude this lecture, let us summarize the decision-making process. If you have one categorical variable and wish to compare observed and expected frequencies, use chi-square goodness of fit test. If you have two independent categorical variables and wish to examine whether they are associated, use the chi-square test of independence. If you measure the same individuals before and after an intervention or under two different conditions, use McNemar's test. This simple decision tree will help you select the correct statistical method with confidence. Thank you for watching this lecture on McNemar's test. I hope you now understand not only how to perform the test in SPSS and Python, but more importantly, when it should be used. If you find this video helpful, please subscribe to the channel, share it with your friends, colleagues, and research scholars, and leave your questions in comment section. In the next lecture, we will study Cochran's Q test, which extends the idea of McNemar's test to situations where the same participants are measured under three or more conditions. I look forward to seeing you in the next video. Thank you.
Always share the videos of Dr. Sachdeva to your friends who are interested in data analysis.